Hello and welcome. This is Math Made Simple, and today we'll be looking at the Circle Theorem, and this is lesson 2 of the Circle Theorem, okay? And we will be looking at angles in the same segment rules. Alright, so but before we dive into our lesson, I want to urge you to subscribe to this channel if you have not done so, because we do a whole lot of math lesson, okay? And so that you can follow our progress. Okay, so let us get into our lesson. All right, so we'll be talking about the Circle Theorem, and for the angles in the same segment rule, it says that angles in the same segment are equal. All right, so we will look at the angles in the same segment. All right, okay, so if we were to draw this circle and draw this chord, and this chord intersect this circle at point A, and this is at point B. All right, so this chord shares this circle into two segments. We have the major segment and we have the minor segment. So this rule is saying that when angles are formed in any of these segments, those angles that are formed in the same segment are equal. All right, so we will see an illustration of that. Okay, so let's say we drew two angles that are in this segment. Okay, so we are saying that point A and B, if we connect point A and B with a chord, we have the minor segment in this side and we have the major segment here. So these two angles, this angle whose vectors is formed at point C, and this angle whose vectors is formed at point D, these two angles are formed in the same segment. So this rule is saying that once angles are formed in the same segment, it means those angles are equal. So it means these two angles are equal. So, and looking at here too, so if we now consider point D and C, and we draw a chord from point D to point C, then we'll see that the arc DC will be forming the minor segment, and the arc DABC will form the major segment. So these two angles whose vectors are at point A and B will be in the same segment, where we to consider a chord that connects point D to point C. So it means angle A is the same as angle B. Okay, so we say if this angle is 34 degrees, it means this angle that is formed at point C is also 34 degrees. And likewise, if this angle is 12 degrees, it means this angle will be 12 degrees. Let's see another one. Okay, so if we have this cycle and we drew these two angles, okay, and are considering point D and C as the points where we would draw our chord. Okay, so it means the arc DC will form the minor segment, and arc DABC will form the major segment. So the two angles that are formed in the same segment here will be angle A and angle B. So it means angle A and angle B are equals according to the rule. Okay, so if this angle B is 23 degrees, angle A will also be 23 degrees. If we were now to use point AB and draw a chord from point A to point B, it means the minor segment now will become the portion of the cycle whose arc is AB, and the major segment will be ADCB. Okay, so in that case, the two angles will be angle D and angle C, which will also be equal. So if this is 51 degrees, it means angle C will be 51 degrees. Okay, so let us see example problems. Calculate angles P, Q, and R from the information given. Okay, so this is a diagram, and we have angle P, Q, and R. So we have to find these respective angles. All right, so for angle P, we say that angles in the same segment. So for angle P, we will consider point D and point C as those points wherein we were to draw the chord. Okay, so the minor segment would be the segment that is formed with this arc DC. Okay, will be the minor segment, and the major segment will be arc DABC. So DABC is one segment, and this angle 27 and angle P are formed in that same segment. So according to the rule, they are equal. So it means angle P is equals to 27 degrees because angle A here is 27 degrees. All right, so for angle Q, okay, so for angle Q, what we will do is we will now consider arc chord AB. So it means the minor segment will be the one that is being formed with this arc AB, and the major segment will be the other segment. So it means these two angles are formed in this one segment. So it means they are equal. So it means we have angles in the same segment. So since we have 29 degrees here, it means angle Q will also be 29 degrees. Okay, so let us see for angle R. If we see angle R, it is that these three angles now form a triangle. So we have a triangle here. So it means we are going to use the interior angles of a triangle. Okay, and we know the sum of the interior angle of a triangle to be 180 degrees. So we say angles in a triangle. Okay, so these three angles are in one triangle, and the sum of them must be 180 degrees. So angle R will be 180 degree minus the 27 degree, also minus the 29 degrees. So that becomes 180 degrees minus 27 degree minus 29 degrees. That will give you 124 degrees. So angle R will be 124 degrees. Okay, so let's see another problem. Calculate angles W, X, Y, and Z from the information given. AD is the diameter of the circle. Okay, so AD is the diameter, and we have to calculate the respective angles here. Okay, so let's begin with angle W. So in order to calculate the value of angle W here, we say that angles in the same segment. So we will consider point B and point C as the points that shares this circle into two segments. So the major segment will be in which we have this point A and point D. So the angles that are formed there must be equal. So angle W is equals to the 15 degrees because they are formed in the same segment. So angle W is 15 degrees. Okay, so angle X. For angle X, we say angles in a semicircle. Okay, so this is an angle in a semicircle. We dealt with this rule before. Okay, since this is the diameter, any angle that is formed in any of the segments considering the point of intersection of the diameter of the circle and that of the sides of that identical triangle, okay, we say is equals to 90 degrees. Okay, so we know that this is 90 degrees, so X is 90 degrees. All right. Then angle Y. Angle Y, if you clearly see here, we see angle Y is in a triangle. This is a triangle here. We have angle Y, angle 90 degree and 15 degrees. They are all in a triangle. So we are going to use that relationship. We say angles in the triangle. So angles in the triangle sum up to 180 degrees. So we have 180 degree minus 90 degree minus 15 degrees will give you angle Y. So that becomes 180 degree minus 90 degree minus 15 degrees, which is 75 degrees. So angle Y is 75 degrees. Okay, so we have to find angle Z. And if you look at clearly here, you see that angle 75 degree and angle Z are along this line AC. Okay, so they are on a straight line. So we know the sum of angles in a straight line is 180 degree. So angle Z will be 180 degree minus 75 degree, which is just 105 degrees. Okay, so it means we have that 105 degrees. So we say that's okay. There are angles in a straight line. So angle Z will be 180 degree minus 75 degree, which is 105 degree, as we have it here. Okay, so let us see another problem. Fill in the missing angles. So we are to fill in the missing angles. Angle A, B, C, D, and E. Okay, so let's begin with angle A. For angle A, we say angles in a straight line. So this angle, we see line BE is a straight line, and 79 degree and A are in a straight line. So the sum of them must be equals to 180 degree. So we subtract 79 from 180 degree, give us angle A. So we have angle A equals 180 degree minus 79 degrees, which is 101 degree. So angle A is 101 degree. And angle B, if you look at B, angle B, these are in a triangle. So we say angles in a triangle, which sum up to 180 degree as well. So you will have 180 degree minus 101 degree minus 19 degrees, which is equals to 60 degrees. So angle B is 60 degrees. Okay, so angle C, we say angles in the same segment. Okay, this angle C, angles in the same segment. So what we do here, we have the segment here. Okay, so our segment will consider point DE as those points that form the two segments. Okay, that shares the circle into two segments. So point B and point A are formed in a major segment. Okay, so it means angle C is equals to 60 degrees because they both are in the same segment. Okay, so we say angle C is 60 degrees. All right, so we move on. We go to angle D, angles in the same segment likewise. So angle D. So this time around, we are going to use point A and B as the points that are going to share this circle into the two segments. So now the major segment is the segment in which we have a point D and point E. So it means angle D is equals to 19 degrees because the two angles are formed in the same segment. So angle D is 19 degrees. Okay. All right. So angle E alternate angles. Okay, so considering this diagram, we'll consider this diagram here. Point C, okay, line C, D, and line AE are parallel lines. You can see that by the arrow. So they are parallel lines. Okay, so the line that intersect these two lines, okay, the alternate interior angles that are formed are definitely equal. Okay, so it means angle 60 is equals to angle 19 degrees plus E. Okay, so in order to find angle E, you are going to subtract 19 degrees from 60 degrees. So you have 60 degrees minus 19 degrees, which is 41 degrees. So it means angle E here is 41 degrees. All right, so that's it.